Okay, in this last video, your handout looks a little bit different than normal. This has some pictures of graphing calculators. So if we were at the school, we would have a set of these calculators that we could use. So that's what this is based on. But I've got a website that is like a equally great financial problem solver. And it's got the same variables and everything. So this should match up pretty well. And I'll show you the website as I go. So we can kind of scratch out this title. This time we're going to be using a TVM solver. This stands for time value money solver. So what's the value of your money over time? Kind of the idea. So using a TVM solver on the internet to solve some annuities. So the website is called Geogebra. There is a link to Geogebra, like algebra, but geometry. So it's Geogebra. Um, is a website, and the link is in D2L, so you can pull that up anytime and try typing stuff in as you watch the video. Sorry, that's so messy. GeoGebra TVM solver. So you can also Google it and find it. All right, so here is how it's going to work. We're going to see questions that look just like what we have been doing in the morning lessons um, with those big formulas. So the questions are going to be the same, but rather than doing all those calculations, we're just going to enter all the numbers into a calculator and have it pop out the answer for us. Okay, so we just need to figure out what format does the calculator want all these pieces of information in. So n is the number of compounding periods. These are all capitals, so we're used to it being little n in the formula, but it's a capital here. Interest rate, we're used to lowercase I, but it's a capital I on this calculator. Um, Something important here is that the calculators want you to enter the interest rate as a percent and not a decimal. So to do our pencil and paper stuff, we have to convert to a decimal. The calculator says don't waste your time doing that, just tell me the percent. Present value, payment, this is like the regular withdrawal. So our formulas have that as R. Future value, we're familiar with. These next two, we haven't used these like notations, but this has to do with how the money is compounded. So compounds per year. For example, monthly would be the number 12. 12 compounds per year. Payments per year is the same idea, but maybe you are wanting to make your payments weekly. So maybe you have weekly payments, even though the interest is being compounded monthly. So those are allowed to be two different numbers. Usually for us, they're going to be the same. So compounding monthly and depositing money monthly, but they could be different. The last part of this says payment and then end or begin. End is like the default, that's what we want. And that just means that your payment is made at the end of each compounding period instead of the beginning. Um, and that is like slightly different. So we're going to make sure we use end. Okay, so that's like what all the buttons mean. I'm going to drag this out of the way for a second and show you what the website looks like. And that is what it's on the left side of the screen there. That's what it looks like when you just open the website up. So the defaults are all zeros for everything except the payments per year and compounds per year. Those both assume you're talking annual unless you say otherwise. And then the other ones, all those zeros, we need to fill in numbers in those spots. Okay, so it does have the exact same variables as what shows up on the graphing calculator pictures in our notes here. Okay, I didn't actually finished that question, so we can enter those things. I'm going to make this small so we can see both. Okay, so n was 20. I'm going to use tab to fill in the next spot. The interest rate was 8%. There is no present value. You're not depositing anything at the beginning. You're going to make annual deposits like later on as regular payments. So there is no present value. The payments are $1,000. The future value is not known yet. So on the graphing calculator that defaults to a 0, you can leave the 0 there or even erase it, since that's the thing we're going to want to find. And then we're compounding annually, so the payments per year and compounds per year are both 1 for annual. So all of these are like things you could solve for, and in this question we want to solve for future values. So I'm going to click on that, and it tells me the future value is 45,761, and it rounds it off to the nearest dollar. It doesn't tell us the decimals there. You might wonder why that's a negative, but the idea is we're going to deposit 1,000, deposit 1,000, deposit 1,000 20 times, and then at the end of all of that, we're going to take it out of the account. So that's why it's assumed to be a negative. They're saying, yeah, you're going to take out that money in the future. Okay, so there's a first TVM question. So a fresh start for a new question. Determine the monthly payments required to accumulate a future value of $10,000 in 4 years. If your payments earn 6.5% interest per annum, compounded monthly. So there's a couple hints here. This one's like already filled in with a little bit of an explanation. So it says, notice you can enter 12 times 4 as the number of years. So we are looking at 4 years and monthly payments. So if we were doing this on paper, we would have written 12 times 4. We're allowed to do that here too. And the calculator is clever enough to turn that into the number 48 when you tab to the next spot. The interest rate was 6.5%. The present value, again, none. We're not depositing anything at the beginning. The payments, that's what we're trying to find. I'm going to erase that for now. The future value of 10,000, I want to take out 10,000 4 years from now, so that's negative. Payments per year, let me just read that again. We're making monthly payments, so there's going to be 12 of them. And the compounding is also monthly, so 12 compounds per year. So that's kind of the story of how to choose each of those numbers. And then in this one, we're finding the monthly payment, so I'm going to click solve for payment. Right, so the question at the end of your handout says, did you get $182.98? Yes. The instructions on here, it says press alpha enter. That's like on the graphing calculator. I hit solve for payment instead. Solve for payment, since we're using that website instead. Okay, so this TVM solver, this is like easy to use. The only thing that have to be careful, I have had to be careful about, is the entering the interest rates as percents, knowing whether or not there's a present value, and in these ones there hasn't been. and realizing that in the future I'm taking out the money, so that's a negative number. So a couple of little things to be careful about, but this is a pretty great tool. All right, I've got one more question I want to do with you. And it says determine the total amount of interest earned on an annuity consisting of quarterly deposits of $15,000 for 10 years if the annuity earns 9% interest per annum compounded quarterly. So I'm going to try to come up with what the variables are, or like without looking at the graphing calculator picture. So determine the total amount of interest earned. We're making quarterly deposits for 10 years. So I think we're talking about future value is what we're going to be trying to find first. And then after we know that, we can work on the interest. So quarterly deposits, those are the regular payments. So R, or payment, $1,500 for a number of years, 10 years, and quarterly payments. So it's going to be 40 of them. The interest rate was 9%. We don't need to do anything to that. What am I missing here? There's no present value. We're not making an initial deposit, just those quarterly ones. The payments per year is going to be 4 quarterly deposits, and the compounding is also quarterly, so 4 for that number as well. So I'm just going to check that against here. N was 40, interest rate is 9, nothing for the present value. Payment 1,500. This one already has the answer filled in, but that looks like I did an okay job of it. So I'm going to hit clear in the Geogebra solver, type those numbers in. Interest rate was 9. Payments are $1,500. These are like deposits, so they're positive, they're going into your account, making your balance higher. The future value is unknown, so I can erase it. And then these were both 4. Okay, so we're going to solve for the future value one last time, and it comes out to negative 95,679. It doesn't show you the decimals, so that's fine. All right, so that's how you can use the TVM solver for, that was a future value question. It is also possible to use it for present value questions, and I'm going to share a separate video that a colleague of mine from Bear Creek put together where he does some of the present value ones.